The dry dock at Yokosuka Naval Arsenal fell silent on the morning of November 8, 1944. Commander Matsuo Fujiwara stood on the scaffolding, 3 stories above the concrete floor, staring at something that shouldn't exist. In his hand was a technical intelligence report, still smelling of fresh ink from the translation department. The paper trembled slightly, not from the autumn wind cutting across Tokyo Bay, but from what the numbers represented. 6 aircraft carriers. The Americans had commissioned 6 fleet carriers in the time it had taken Japan to complete one. Fujiwara had spent 17 years studying naval architecture at the Imperial University, another 12 in the design bureaus of Kure and Yokosuka. He absolutely knew that you couldn't build a carrier that quickly. The tolerances were too tight. The systems are too complex. The welds are too critical. Yet here, in captured American technical manuals recovered from a downed B-29, were the construction schedules. Methodical, documented, impossible. Below him, the hull of Shinano rose from the dry dock, the converted Yamato-class battleship that represented Japan's final hope for naval aviation superiority. Started in May of 1942, she wouldn't be ready for sea trials until this month. 2.5 years of construction. Every plate had been hand-fitted. Every frame is personally inspected. Every rivet placement was supervised by master craftsmen whose training stretched back to the Meiji era. The American carriers in that report, 12 to 18 months from keel laying to commissioning. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Fujiwara descended the scaffolding, his mind churning through the implications. He had been taught, they had all been taught, that Japanese craftsmanship was superior precisely because it was meticulous, because it was slow, because it honored the traditions of shipbuilding that stretched back centuries. The Americans, with their mass production mentality, their automobile factories, their obsession with interchangeable parts, they were supposed to be incapable of building anything as sophisticated as a fleet carrier. The report said otherwise. What Commander Fujiwara couldn't know standing in that dry dock in November of 1944, was that the impossible American production rates weren't the result of superior engineering or better raw materials. They were the result of what Japanese naval architects had dismissed as a catastrophic design flaw, a manufacturing error so fundamental that it violated every principle of traditional shipbuilding. The Americans had deliberately designed their carriers to be built wrong. To understand how American shipyards achieved what Japanese engineers considered impossible, you have to understand what naval construction meant in 1941. 4 centuries shipbuilding had been an art of precision and uniqueness. Every vessel was essentially a custom build. Plates were cut to fit specific frames. Systems were routed around obstacles. Adjustments were made on site by skilled craftsmen who could compensate for the minor variations that occurred in every hull. This was true in Britain. It was true in Germany. It was absolutely true in Japan, where the philosophy of monozukuri, the art of making things with dedication and precision, elevated shipbuilding to something approaching spiritual practice. When Japan laid down the Shokaku-class carriers in December of 1937, the design called for hand-fitted armor plates, custom-fabricated structural members, and systems that were integrated during construction based on the judgment of master builders. The result was magnificent. Shokaku and Zuikaku were perhaps the finest carriers ever built, with balanced designs that incorporated lessons from years of carrier operations. They were also slow to build, 3 years from keel to commissioning, and essentially impossible to repair quickly because every component was unique to that specific ship. The Imperial Japanese Navy understood this trade-off. Quality took time, Excellence required craftsmanship. You couldn't rush perfection, and in naval warfare, where a single torpedo could end a billion-yen investment, perfection mattered more than quantity. American naval architects saw the same problem and came to a radically different conclusion. In 1934, a design team at Newport News Shipbuilding was struggling with the construction timeline for USS Yorktown, the lead ship of a new carrier class. The Navy wanted faster construction, but traditional shipbuilding methods had hard limits. You could add more workers, but only up to a point. Beyond that, they got in each other's way. You could extend work hours, but exhausted craftsmen made mistakes on critical welds. The breakthrough came from an unlikely source: Henry Kaiser's automobile production experience. Kaiser, who would later become famous for his Liberty ship production, had been consulting with Newport News on industrial efficiency. His question was simple and devastating. Why are you building ships like custom furniture when you could build them like cars? The traditional answer was obvious. Ships weren't cars. They were too large, too complex, too variable in their construction. No two sections of a whole were quite identical. Frames varied slightly. Curves changed. You needed skilled workers to compensate for these variations during assembly. Kaiser's response changed naval warfare. Then make them identical. This is where the factory error entered American carrier design, though it wasn't an error at all. It was a deliberate choice that Japanese engineers, when they eventually captured the technical specifications, interpreted as a fundamental mistake in engineering. Practice. American designers decided to build carriers in modules, completely prefabricated sections that were manufactured separately and then assembled like massive building blocks. But here was the revolutionary part. Instead of designing modules to fit the specific curves and contours of a traditional ship hull, they designed a hull that could be built from standardized, interchangeable modules. This meant accepting imperfections that would make any traditional shipwright recoil. Angles that weren't quite optimal for hydrodynamics. Spaces that were slightly larger than they needed to be. Structural elements that were overbuilt because they had to work in multiple positions. Weight distributions that weren't perfectly balanced. To Japanese naval architects, this looked like lazy engineering. Accepting inferior design to make construction easier. They saw the slightly blockier hull forms of American carriers, the less elegant curves, the visible seams where modules joined. In technical reports, Japanese analysts noted these flaws as evidence that American carriers were inferior products rushed into service. What they missed was the implication of those flaws. At the Four Rivers Shipyard in Quincy, Massachusetts, in March of 1942, USS Essex was under construction in a way that would have seemed chaotic to a Japanese observer. The ship wasn't being built from the keel up in a single dry dock. Instead, sections were being fabricated simultaneously in dozens of different locations across the shipyard. In one building, workers assembled the bow section, a complete, prefabricated unit that included not just the hull plating but pre-installed crew quarters, fully wired electrical systems, and plumbed piping runs. In another building, the island superstructure was taking shape as a complete module, with radar equipment, fire control systems, and ventilation already integrated. The flight deck wasn't being laid plate by plate onto the hull. It was being constructed as a series of massive panels in a separate facility, each panel complete with arresting gear foundations, catapult tracks, and non-skid coating already applied. When these modules came together, something remarkable happened, because each module was built to exacting, identical specifications, the same specifications used for modules going into other Essex-class carriers. They fit together with mechanical precision. The bow section built in Building 12 would mate with the midships section from Building 7 with tolerances measured in fractions of an inch. This wasn't possible with traditional construction methods. When you hand-fit every component, each ship becomes unique. The bow of Shokaku couldn't be swapped with the bow of Zuikaku. They were sisters, but they weren't identical. American Essex-class carriers were identical in ways that violated traditional shipbuilding philosophy. The flight deck panels from CV-9 could theoretically be installed on CV-10. The engine room modules were interchangeable. Even complex systems like fire control computers used standardized mounting points that were identical across the entire class. To Japanese engineers analyzing captured plans, it looked like the Americans were building the same ship over and over, which seemed like an admission that they couldn't handle complex custom designs. What they failed to understand was that building the same ship over and over was exactly the point. Commander Fujiwara had encountered this concept before, though he hadn't recognized its implications. In 1939, he'd been part of a technical delegation that visited the Ford River Rouge complex in Michigan. The delegation was ostensibly there to study automotive production techniques, but the real purpose was industrial intelligence, understanding American manufacturing capacity. Fujiwara remembered standing on an observation platform watching the assembly line below. Every 93 seconds, a completed automobile rolled off the line. The guide had mentioned almost casually that the factory produced 7,000 cars per week. The number was staggering, but what stayed with Fujiwara was something else. He'd asked the plant manager how they achieved such precision with so many workers. The answer seemed almost childishly simple. We don't train workers to build cars. We train them to install part number 47 in position 12B. They do that one job perfectly thousands of times. At the time, Fujiwara had dismissed this as a typical American reduction of craftsmanship to mere mechanical repetition. A Japanese shipyard worker was an artisan who understood the entire vessel. An American worker was a cog who knew one repetitive task. Standing in Yokosuka Dry Dock in 1944, Fujiwara finally understood what he'd missed. The Americans hadn't dumbed down shipbuilding. They'd transformed it into something that could be done by ordinary workers at extraordinary speed, and the factory error of modular standardization was what made it possible. By late 1942, the implications were becoming clear even in Tokyo. The Naval General Staff received reports from multiple sources: intelligence intercepts, technical analysis of captured equipment, even neutral observers in South America who watched American ships pass through the Panama Canal. The reports all confirmed the same impossible reality. American shipyards were producing fleet carriers faster than Japan could produce destroyers. The numbers told a story that violated everything Japanese naval planners had assumed about industrial warfare. In 1942, American yards laid down 9 Essex-class carriers. 9 identical hulls, each built using the same modules, the same plans, the same assembly sequence. Japanese yards laid down 1 fleet carrier, Taiho, a custom design incorporating lessons from Midway. Taiho would take 3 years to complete, the first Essex-class. Carrier CV-9 took 17 months from keel laying to commissioning. But the real devastation was in what those numbers meant for repair and replacement. When Shokaku was severely damaged at the Battle of the Philippine Sea in June of 1944, she had to return to Kure Naval Arsenal for repairs. The damage wasn't catastrophic, mostly to her flight deck and forward elevator system, but the repairs took months because every component had to be custom fabricated to fit her specific configuration. When USS Franklin was hit by 2 armor-piercing bombs in March of 1945, damage far more severe than what Shokaku suffered, she was repaired and returned to service in weeks. The damaged sections were cut out and replaced with prefabricated modules that bolted into the standardized mounting points. Workers didn't need to measure and custom-fit replacement plates. They installed Module 7B, which was identical to Module 7B in every other Essex-class carrier. This was the hidden power of the factory error. Standardization didn't just make construction faster, it made battle damage repair almost trivial. The entire American carrier fleet could draw on a common pool of spare parts and prefabricated sections. Japanese carriers were magnificent individuals, each requiring unique components that only existed in the shipyard that built them. Lieutenant Takeshi Maeda, a naval architect assigned to the Technical Research Institute in Meguro, spent the winter of 1943 trying to understand how American production rates were possible. He had access to excellent intelligence, captured technical manuals, photographs from reconnaissance flights over American shipyards, even defector reports from European engineers who'd worked with American firms. The data kept pointing to the same conclusion, which Maeda found almost offensive in its implications. The Americans weren't building better carriers. They were building adequate carriers very, very quickly. And in industrial warfare, adequate multiplied by quantity defeated excellent multiplied by scarcity. Maeda prepared a report for the Naval General Staff that winter. In it, he laid out what he discovered about American modular construction techniques. He explained how the standardization of components, what he termed the sacrifice of optimal design for industrial efficiency, allowed American yards to produce carriers at rates Japan couldn't match. His conclusion was carefully worded but devastating. Japan could not win a construction race against American shipyards. The empire's emphasis on craftsmanship and custom engineering, which produced superior individual ships, made it impossible to match American production volume. The report was filed and largely ignored. The Naval General Staff understood the mathematics, but changing Japan's entire industrial philosophy in the middle of a war was impossible. Japanese shipyards didn't have the machine tools for mass production of standardized components. Workers were trained in traditional craftsmanship, not assembly line techniques. The entire supply chain was built around custom fabrication. Even if Japan wanted to copy American methods, it would take years to retool. Years Japan didn't have. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By 1944, the strategic implications were undeniable. At the Battle of the Philippine Sea in June, the Japanese mobile fleet sortied with 5 fleet carriers, representing essentially the entire surviving carrier strength of the Imperial Navy. The American Fifth Fleet had 15 carriers, 7 of them Essex-class ships that hadn't even existed 2 years earlier. The battle was a massacre. Japanese naval aviation, already depleted by casualties and inadequate training pipelines, lost approximately 600 aircraft in what American pilots called the Great Marianas Turkey Shoot. 3 Japanese carriers were sunk, including Taiho, the newest and most advanced carrier in the fleet, the one that had taken 3 years to build. The Americans lost no carriers. Several were damaged, but the damage was repairable precisely because of the modular construction that Japanese engineers had dismissed as inferior design. Commander Fujiwara watched Taiho sink through a periscope. He'd been transferred to submarine duty by then, part of the desperate reshuffling of experienced officers to fill gaps in the decimated fleet. He had helped design Taiho's armor scheme. He knew every detail of her construction, every custom-fitted plate, every precisely calculated weight distribution. She went down in less than 8 hours after a single torpedo hit, not because the hit was particularly devastating, but because damage control efforts were hampered by the unique, custom nature of her systems. Repair teams couldn't simply swap out damaged components. They had to improvise, adapt, work around the specific configuration of that specific ship. Fujiwara surfaced after dark and watched the oil slick burning on the ocean. Somewhere in that darkness were 60 carrier-qualified pilots who died with the ship, pilots Japan couldn't replace. Somewhere beyond the horizon were American carriers that could be replaced faster than Japan could sink them. The true scale of the factory error's impact became visible in the final year of the war. Between January and August of 1945, American shipyards commissioned 14 fleet and light carriers. Japan commissioned 0. Not because Japanese shipyards had been destroyed, though bombing raids certainly impacted production, but because the carriers under construction required resources and time that no longer existed. Shinano, the converted Yamato-class battleship that Fujiwara had inspected in November of 1944, was commissioned on November the 19th. She was the largest aircraft carrier ever built, displacing 72,000 tons. Her armor was the thickest ever installed on a carrier. Her design incorporated every lesson learned from 4 years of carrier warfare. She survived 10 days. On November 29th, the submarine USS Archerfish put 4 torpedoes into Shinano's starboard side. The damage was serious, but shouldn't have been fatal, not to a ship with that much armor and compartmentalization. But the crew was inexperienced. The damage control teams unfamiliar with the ship's custom systems, and the watertight integrity compromised by rushed construction in the final months. Shinano capsized and sank 7 hours after being hit, taking over 1,000 men with her. She had never launched a single aircraft in combat. The resources invested in her construction, the steel, the labor hours, the engineering expertise, represented perhaps a dozen destroyers or several dozen submarines that Japan desperately needed. The Americans, meanwhile, were producing carriers so quickly they were running out of names. The Essex-class production run eventually reached 24 ships. 24 identical hulls, each built in 12 to 20 months, each capable of carrying 90 aircraft, each using the same standardized components that made repair and refit almost trivial. Lieutenant Maida spent the final months of the war at the Technical Research Institute, compiling a comprehensive study of American industrial methods. It would never be published. The documents were burned in August of 1945, as Tokyo prepared for invasion. But Maeda's notes survived in his personal papers, discovered decades later by historians. One passage stands out. "We believed our craftsmanship was our strength. We built each ship as a masterwork, unique and optimized. The Americans built adequate ships in enormous quantities. In industrial warfare, adequacy repeated 100 times defeats perfection repeated 10 times. This is not a pleasant truth, but it is true nonetheless." The mathematics was brutal. Japan entered the war with 10 aircraft carriers and built 16 more during the conflict, for a total of 26. Sounds substantial until you compare it to American production. The United States entered the war with 7 carriers and built 141 more, including escort carriers, during the conflict. Even limiting the comparison to fleet carriers, the numbers tell the story. Japan built 6 fleet carriers during the war. The United States built 17 Essex-class fleet carriers alone, plus multiple other classes. The factory error, the deliberate choice to standardize components, to sacrifice optimal design for production efficiency, to build adequate ships quickly rather than perfect ships slowly, had won the Pacific War before the first shot was fired at Pearl Harbor. Japan's carrier fleet was doomed not by tactical failures or strategic mistakes, though there were plenty of both, but by industrial philosophy. Commander Fujiwara survived the war. He was aboard a submarine that was in port for repairs when Japan surrendered in August of 1945. In the chaos of the occupation, He returned to Yokosuka, where he'd started his career, where he'd stood on scaffolding above Shinano's hull and held that impossible intelligence report. The dry dock was empty now. The tools were silent. American occupation forces had photographed everything, documented the construction facilities, and interviewed the workers. They were curious about Japanese methods, academic in their interest. They'd won, after all. They could afford to be generous in their curiosity. An American naval engineer, a lieutenant commander from the Bureau of Ships, sought out Fujiwara specifically. He'd read some of Fujiwara's pre-war technical papers on carrier design. He wanted to discuss Japanese construction philosophy, the emphasis on craftsmanship and custom fitting. Fujiwara asked the question that had haunted him since November of 1944. How did you build so many carriers so quickly? The American's answer was almost dismissive in its simplicity. We designed them to be easy to build. Not optimal, not perfect, just easy to build in quantity. Every component standardized. Every module is interchangeable. We sacrificed maybe 5% efficiency in the final design to gain 500% efficiency in construction. Fujiwara asked if that wasn't a dangerous compromise, accepting inferior design to make production easier. The American shrugged. Inferior compared to what? A perfect carrier that takes 3 years to build and can't be quickly repaired is inferior to an adequate carrier that takes 1 year to build and can be fixed with standardized parts. We learned that from Henry Ford, not from naval architecture. This was the heart of it, the fundamental philosophical difference that determined the Pacific War's outcome. Japanese naval architecture was rooted in the tradition of monozukuri, the pursuit of excellence through dedicated craftsmanship. Every ship was a work of art, optimized and refined. American naval architecture was rooted in industrial engineering, the pursuit of adequacy through systematic production. Every ship was a product, standardized and interchangeable. In peacetime, Japanese methods produced better ships. In wartime, American methods produced more ships. And in industrial warfare, more ships defeated better ships. The final irony, the one that would have devastated Fujiwara if he'd known it in 1941, was that the factory error of modular standardization wasn't even an American innovation. It was a Japanese innovation that Japan had failed to apply to its own naval construction. In the 1920s, Japanese automobile manufacturers had pioneered modular assembly techniques, studying and in some cases surpassing American methods. The Toyota production system, which would revolutionize global manufacturing after the war, was already taking shape in the 1930s. Japan understood mass production. Japanese engineers had helped invent it. But the cultural weight of monozukuri, the reverence for craftsmanship, the belief that important things like warships, deserved individual attention and custom engineering, prevented Japan from applying its own industrial innovations to naval construction. The philosophy that made Japanese swords legendary for 1,000 years made Japanese carriers inadequate for industrial warfare. By 1950, Fujiwara was teaching at the University of Tokyo, training a new generation of naval architects in a Japan that no longer had a navy. He told his students about the war, about Shinano and Taiho and Shokaku. He showed them the numbers. 6 American carriers for every 1 Japanese carrier. He explained the modular construction techniques, the standardization philosophy, the factory error that wasn't an error at all. His final lecture each semester focused on a single point. Engineering is not just about designing the best possible solution. It is about designing the best possible solution that can actually be built, in the quantities needed, in the time available. Perfect is the enemy of adequate, when adequate can be produced in quantity. The students would nod, take notes, and absorb the lesson. Fujiwara wondered if they truly understood. He hoped they did. He hoped Japan would never again make the mistake of pursuing perfection when adequacy would win the war. The numbers still haunted him. 6 carriers at the time Japan built one. Not because American engineers were smarter. Japanese engineering was world-class. Not because American workers were more skilled. Japanese craftsmanship was legendary. But because American industrial philosophy accepted an impossible factory error, building ships that were merely adequate in quantities that were absolutely overwhelming. In the end, that was enough. More than enough. The Pacific War was won not in the tactical brilliance of Midway or the strategic vision of island hopping, but in the shipyards of Newport News and Quincy and Philadelphia, where ordinary workers installed standardized modules into identical hulls, one after another, faster than Japan could sink them. Commander Fujiwara understood this by November of 1944, standing in Yokosuka dry dock with an intelligence report in his trembling hands. Understanding it didn't change the outcome. Understanding it didn't build Japanese carriers any faster or make American carriers any slower. Understanding it just meant he knew exactly how the war would end and why, and that there was nothing Japanese naval architecture could do to prevent it. The factory error had already decided the Pacific War. Everything after that was just mathematics working itself out in blood and steel and burning oil on dark water. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.